Hello, my name is Victor Ramos, and unfortunately, this will be the last teaching video of my semester. I just wanted to say thank you once again to Professor Kwan. I hope you enjoy your summer. But, anyways, today we will be learning logarithmic functions and their graphs. What this means is I will teach you today what a logarithmic function is and how we are able to graph them. So, a logarithmic function is pretty much an exponential function, but the inverse of that exponential function. Let's put it this way. This is your base for a logarithmic function. It's y equals log of base is x. Now, the b is the base of the exponential of the logarithmic function. If this was an exponential function, this would be the base of it. The x is the equation, which is like the answer of what we're trying to get, and the y is actually the exponent of the base. Let me write this down so you'll be able to see it. Base, exponent, and equation, which is a fancy word for saying answer. So if we wrote this in exponential form, it would be b to the power of y equals x. So let's plug in an actual function with numbers and all that stuff, and so that you'll be able to see what we're actually talking about. I'm going to keep this up here as a reference not only to myself but to you as well. So let's do log base 2 times x plus 5 equals 3. Oh, there's one thing I always want to mention. When it comes to the inside of a log, as in this example, x plus 5, it cannot be 0 because you're trying to find the equation of this using the exponent, which is the equation of a log, if you understand what I mean. Because if you put the exponent, if you made this 0, that would make the equation 0, and obviously that is impossible, as well as the base of any logarithm cannot be 1, because if you try to to find the square root or the cube root or the 99th exponential power of 1, the answer will always be 1. So those are the two rules of when it comes to logarithmic functions. The inside of a log cannot equal 0, and the base of a logarithmic function cannot be 1. So, continuing on with this, what we want to do is what I told you before, is transfer this into exponential form and find our x. So, we would do 2 to the power of 3, because remember, the y is the exponent. 2 to the power of 3 equals x plus 5. Now, if you know 2 to the power of 3, it's 2 timing itself 3 times. And 2 times 2 is 4 times 2 is, you guessed it, 8. Let me write it here instead of the 2. You know what? Let me put it on the bottom so you can have all the reference you need. 8 equals x plus 5. So, using basic algebra, what plus 5 gets us 8? You guessed it. You're correct. I knew you were smart. It's 3. And this is the answer to our x in our logarithmic function. Now, in the next equation, I'm going to show you how you're able to graph said function, but we're going to do a different one just to make it a little interesting, a little different. Now, the next equation, because of the fact we're trying to graph it, it becomes f of x log base 3 x minus 1. Now, do you remember what I told you about this cannot equal 0? Well, in graphing, to be able to find where it's going to go, it makes it easier to find the vertical asymptote. Now, what does that mean? Let's just do a 5 by 5 graph. And so the vertical asymptote is more so an invisible wall, letting you know that your graph is not going to pass the other side of said wall. In this case, if it was on the 1, the vertical wall will be here, and the graph will never pass that sign. So to find the vertical asymptote, what I said previously becomes useful. We have to make this equal 1 equal 0, and that number for x is our vertical asymptote. So let's separate this from the logarithmic function. Let's just do x minus 1 equals 0. Now, what number minus 1 will equal 0? Correct. It is 1. So that shows that the vertical asymptote, I apologize if I wrote this wrong, I'm trying to do math, not English, will be 1. So in our graph of 5 by 5, we're going to put a 1 here, just to give you some idea. We're going to do invisible dashes, letting you know that it can't pass by the 1. So given this, what can we do to find our coordinates? Very, very simple. We use an x and y graph chart. We plug in values for y, and then that's how we get our x coordinate. We start off with -2. So one thing I also forgot to mention is that it has to be a number greater than 0, so it can never be a negative number. So let's start 1, 2, 3, and so on and so forth. That's one thing I forgot to mention. It has to be greater than 0. And it also cannot be 1. As well as the inside of the log cannot equal 0. So let's plug in these features real quick into y. And so let's inverse this. So 3, let's just say y equals 1. In terms of this, it will be the f of x minus 1. So that's 3. So boom, that stays 3 because 3 times itself, which is not another number, which is just 3, equals 1. And so this would mean that the x equals 4, because 4 minus 1 equals 3. So that means our first coordinate is 4 over 1. So let's do that. 4x, 1y, so it looks about right here. Boom, put that right there. Now let's plug in 2 to this equation. And like I said, we're going to reverse it to make it easier for us to find it. So let's do base 3, with the y being 2 this time, equals x minus 1. So, what's 3 times 3? You guessed it, 9. And what's 9? And what's x minus 1? That'll get us 9. You guessed it, 10. So now, we go 10, 2. I'm going to put this even more, because I didn't realize that this, what happened? Let's put it up to 20 just for now. So now, put this over here, because it was 4, 1. Now we put it to 10, 2, which should be around over here. And now let's plug in the same, but instead of the 2 for the y, we're going to put in a 3. So everybody know what 3 times 3 times 3 is? So it's pretty much 3 times 3 is 9, because we know 3 squared equals 9. Now 9 times 3 equals, you guessed it, 27. And what minus 1 will get us 27? You guessed it, 28. So now we got to make our graph even bigger. And this is where logarithms come into use, because it gives you an understanding to be able to shrink said numbers. And so now we got to collapse these dots a little more closer now, because it's so much bigger now. So now, at the 3, we put it right here, because it's right before 37. And so now you start at the 1 because you know that it's never going to go past it, and there is your line. And that is how you understand logarithmic functions and as well as the ability to graph them. My name is Victor Ramos, and I hope you all have a great summer.